Okay, so section 6 deals with a library of parent functions. Okay, parent functions are just the most basic versions of that type of function you can have. Okay, that's what it gets into. So you have quite a few different types of functions to deal with. But to start off with, we have just a basic linear function. Now, this isn't a parent function because it's not the most basic version. This is a general function because A and B could be anything the way this is written. What does this function look like? It's a line. Linear function, line, right? What if it's a line that has to be a function? What's its domain going to be? All real numbers. Okay, it could be anything. What would its range be? All reals as well. Okay. What would the y-intercept be? Well, as far as like coordinate goes, 0 and b. So y-int is 0 and b. What about the x-intercept? Okay. Now, when we first look at this, y-intercept's easy because we call this thing slope-intercept form, right? The thing is, you can always find the y-intercept by making x what? 0. That's why this thing's so easy. That's why we can just use the b, is because if I make x 0, ax goes away. So if I want to find the y-intercept, or the x-intercept, I mean, what would I do? Yeah, solve for x. In other words, make y equal to 0. So the idea here is I'm going to make this 0 equals ax plus b. And I'm going to solve that. Okay. Move over the b. What do you get for x? Negative b over a. So then as far as a coordinate goes, what would that look like? Negative b over a and 0. And it's always going to be that way. Does that make sense? All right. When would this graph, how would you know just from looking at the function that this graph is increasing? If what? Slope is positive. So in other words, what letter here? What's your slope? A. So in other words, if a is greater than 0. When would you know it's decreasing? A less than 0. When would you know it's constant? A is equal to 0. Not too bad. Okay? Now some things with linear functions, though, because of the function notation, they'll present them in a little bit strange ways. But I make sure I know a few of those weird ways. So some of the problems that look a little bit odd, do a couple of them. Because this one looks weird when you first glance at it, but really is a very simple problem. This is an Algebra 1 problem. Probably pre-algebra, honestly. It just looks weird. Because what information are they actually giving you? 2 coordinates, 2 points. What's this combination here represent for a point? Negative 2 and 6. And 4, negative 9 for the other. Okay? So then if I want to write a linear equation for a linear function for this, what do I need to find next? Slope. So, good old slope formula. Subtract the y's. Subtract the x's. Okay? What do I get on top? Go for it.
Doesn't the 2 have to be 1?
Why?
Because it's y2 minus y1 and x2 minus...
Yeah, you got to make sure you keep those lined up. I'll still have pre-calc students make that error. Okay? Because honestly, most people try to avoid negative signs, so they'll switch it like that. Make sure these two come from the same coordinate. Okay? So on top I get bottom negative 6, which simplifies out to negative 5 over 2. So then what do I need? Y-intercept. So how do I go about that? Say again? That would give me, well, I don't have a function to actually do that with, but Plug into what? Yeah. Remember, you have slope-intercept form, right? What I don't know if that slope-intercept is the intercept part. I know the slope, we just found it, -5/2. And conveniently, you're given a coordinate, x and y, right? So use it. -2 and 6 plus b has to work. Now, there is also a point-slope form. I usually never bother using it, but you can if you want, if you're comfortable with it. If I need to find b, I just plug in everything but b. You get 6 is equal to what? 5 plus b. So b is 1. So then your function looks like what? Close, but no. F of x is equal to what?
F of x is equal to -f(x) plus 1.
There we go. Does ask for a function, not just an equation.
So why is it wrong?
I'm not going to penalize you now, but I just want you to realize there is a difference there. Okay, I wouldn't make it on homework. I might make it cost you points, but we're not grading homework. On the test, I wouldn't make it cost you points. Okay, your linear functions, you have actually two types of parent functions. You have the identity, and you have the constant. Now, if for the identity, what's 0 there? If I think about this as the function of a line, what's 0? No, I'm sorry. The default function on the previous page, what's 0 there? The y-intercept 0. Okay, for the identity, your y-intercept 0 and your slope's locked in at 1, so you get a diagonal going through first and third. For the constant function, what's 0? The slope, a. Okay? Now they give you c instead of b, but that just honestly out of habit. So all that is, the line looks like what? Horizontal. Now it's not determined to go through any particular point other than the line is y equals c. Okay, so it's just a horizontal line and that diagonal that splits the quadrants. Next up, go from linear to quadratic. They call it a squaring function because you're peeling off all the excess. This is the parent function. So f of x is equal to x squared. What's it look like? Parabola. That's standard parabola. What was the domain of that parabola? All reals. What's the range? Yeah. Why? So there's a couple different ways you can write it. The book's going to write it this way: all non-negative real numbers. Okay, so the book will write it that way. If you wrote y is greater than or equal to 0, that's fine. Intercepts. The origin's the only one. Symmetries. Reflection of symmetry over the y-axis. When is this graph increasing? Yeah, when x is greater than 0, or if I'm using interval notation, what would it look like? 0 to infinity. Decreasing? Negative infinity to 0. So remember, you're going from left to right. So you're going, even though this arrow is pointed up, the idea is as you come in from the left, you're going downhill till you get to that origin. Then you're going uphill after that. Always from left to right. Does this one have a relative min, relative max? Yeah, it has a min. And where at? At the origin.